I'm the federal point of contact for used nuclear fuel disposition. Now, since I'm at a remote site, I'll need to have some help flipping the charts as we go along. And I'll be doing 3 presentations this afternoon. Chart 2, please. The DOE Office of Nuclear Energy mission statement focuses on advancing nuclear power as a resource through research, development, and demonstration. The used fuel disposition mission focuses on the identification of alternatives and the conduct of scientific research and technology development to enable storage, transportation, and disposal of used nuclear fuel present and future. Chart 3, please. At a high level, Chart 3 shows the Office of Nuclear Energy mission, R&D objectives, and enabling technologies. Note, substantial fuel cycles is the 3rd box under R&D objectives. Chart 4, please. Organizationally, just a quick view of the organization. The DOE-NE organization chart shows the Office of Used Nuclear Fuel Disposition, Research, and Development. It's the center of chart, 2nd box from the bottom, under the Deputy Assistant Secretary for Fuel Cycle Technologies. Chart 5, please. This chart shows the National Lab participants, and you can read them for yourself, but these are the labs that help us get all the work done. Chart 6, please. The grand challenge for this campaign is to provide a sound technical basis for the safety and security of long-term storage, transportation, and disposal to support used nuclear fuel management and disposition pathways. Chart 7, please. Research needs under storage and transportation are the development of the technical bases for storage and transportation after extended storage, that's extended storage, as well as for transportation of high burn-up fuel. Research needs under disposal are to provide a sound technical basis for multiple viable disposal options when national policy is ready. Also, to identify and research associated uncertainty, to increase confidence in concepts' robustness, to reduce the impact of site-specific complexity, and to develop the tools to manage the above. Chart 8, please. Chart 8 shows storage system components from the pellets and the assemblies to a vertical configuration of a cask to an independent spent fuel storage installation, or ISFSI, with a mention of monitoring systems on the lower right. Chart 9, please. Chart 9 shows a visual depiction of storage, transportation, and disposal concepts and addresses the goal of technologies development and assessing performance of waste forms. Chart 10, please. This starts to get a bit wordy, and I will not read you the key university research needs for storage, but following the issuance of the Blue Ribbon Commission on America's Nuclear Future final report in January 2012, interim storage of spent nuclear fuel from reactor sites has gained additional importance and urgency for resolving waste management-related technical issues. It also provides an opportunity for the scientific community to bring forward new conceptual designs and innovative research in this area. Chart 11, please. Again, I will not read you the key university research needs for storage. Technical issues related to transportation of used nuclear fuel have been generally addressed by past industry studies. However, issues related to transportation of used nuclear fuel after prolonged storage periods provide new challenges. And now these are going to be prolonged storage periods. Chart 12, please. Once more, I will not read you the key university research needs for disposal. Assessments of nuclear waste disposal options start with the degradation of waste forms and consequent mobilization of radionuclides, reactive transport through the near-field environment, waste package and engineered barriers, and transport into and through the geosphere. give you just a moment to read those. Chart 13, please. Finally, research needs support the development of modeling tools or data relevant to permanent disposal of used nuclear fuel and high-level radioactive waste in a variety of generic disposal concepts, including mined repositories in clay, shale, salt, and crystalline rock, and deep boreholes in crystalline rocks. I'll give you just a moment to read those also. And that concludes the presentation portion. I'd be happy to try to answer any questions that anyone might have.
No, JC, we don't have any questions currently, but we'll stay on the line for 2 or 3 more minutes to see if any come in. So if you could just hold.
Absolutely.
We'll wait.
Okay.
JC, here's the first question. Regarding transportation, have all modes of transportation been studied? Is there nothing left?
The modes that we would be looking at are by rail and by perhaps heavy haul, because as most people are aware of, there is not a rail line that extends to the and to many individual locations. That heavy haul might be necessary. There might be a facility required to transition from rail to a heavy haul operation. And significant work has been done in rail transportation. We're currently looking at the degree of shake, I'll use the term shake, that would be involved of the casks and assemblies, and whether there would be any degradation there too. There are considerations for lengthy heavy haul that might be looked at. There is a possibility that in some instances there might be short transportation needs regarding barge transportation. So these are some of the different modes that would exist depending on where the used nuclear fuel or high-level waste would be coming from.
Okay, here is the next question. For the transportation task, by advanced modeling approaches, do you mean mechanistic or also probabilistic?
Mechanistic mostly. We're looking at what are the real world what are the real world complications of things that we're going to have to deal with in actually executing a transportation program. There's a great deal of machinery that would be involved. There's a great deal of public interaction that would be involved, but mostly we're looking at the mechanics, I'll have to say, of a transportation effort. Materials that would be involved, structural integrity, disruptive scenarios to relevant transportation, transportation behavior of high burnup and advanced fuels, that sort of thing. Does that answer the question?
I think it does. They can follow up if they'd like. We'll see.
We'd be happy to provide further written responses on the NEOP website to any questions that are submitted.
Okay, JC, the next question is, Could you continue the discussion of transport analysis through geologic media? Is there an interest in models for prediction, experimental techniques for quantifying transport resistance of certain materials, or a combination?
The short answer is yes. There are several different parameters that we're looking at. We are not looking at anything that is currently at anything that is media specific. By that I mean all media are open to proposals. Clay, salt, shale, welded tough. The geologic medium has not been identified as of this point because of the possibility of the location of a geologic repository in a consent-based locale, and so the medium has not been identified. Now, with regard to research and experimentation, I'll use, for example, a salt environment. Would heat loading from spent nuclear fuel cause a large-scale salt plasticizing where the packages would begin to move and drifts would begin to move, and versus would any water existing in the immediate environment, by that I mean within the first 10 meters, would they be would that water be forced away in brine solution, be forced away from the packages themselves, and the salt solidify? That there are different concepts as to how, or visualizations as to how the salt would react in both the near field and the far field. Those are the types of questions that we would be looking at.
Does the interest in transport extend to concrete as well as soils and other geological forms?
I don't understand the question, because if the questioner could expand on that question, we would not transport anything concrete. That maybe I don't understand the question.
We can have him submit a clarification.
Yes, please.
The next question is, are economic analyses included in this study?
Economic analyses could be proposed. As a matter of fact, they would be very interesting because, again, we do not know the location of an interim storage facility, a consolidated interim storage facility. There may be one or more in any given part of the country, east or west, north or south. We're looking at non-location specific, but any parametric studies that could be done would be considered. Parametrics would involve, of course, costs. Under Nuclear Waste Policy Act 180C, there are first responders that need to be notified and trained, and economic evaluations that would include those parameters would be considered.
Okay, JC, we have a clarification on that concrete question. Is there an interest in being able to measure or model transport of ions, et cetera, through a concrete liner or barrier?
Oh, I see. The short answer would be yes. I would need to get further input in that regard. I don't have the information that I would need to solve that question, or rather to answer that question. If that question could be submitted and I could provide further information at a later time.
Okay, the next question is for FC 4.3. Should the proposals involve both experiment and modeling, or is experiment only or modeling only acceptable?
I'm sorry, 4.3?
Yes, 4.3.
Okay, hold on. Oh, I see. 4.3. That's disposal. Repeat the question, please.
Does it have to be a combination of experimental and modeling, or can it be one or the other?
I would say that both would be considered, would be looked at. Of course, modeling is encouraged, and that would probably be more attractive. I'll use that term, or have more capability to provide a little bit more bang for the buck. But I think both would be considered.
Okay, the next question is there a need for CFD modeling and experimental validation for spent fuel thermal management under different environmental conditions?
CFD modeling. What, could you give me that acronym? What is that acronym?
John, do you know what CFD? Computational flow dynamics. Oh, fluid dynamics, excuse me.
And okay, and now repeat the entire question.
Is there a need for computational fluid dynamics modeling and experimental validation for spent fuel thermal management under different environmental conditions?
The thermal loading, I think the question is addressing thermal loading, and thermal loading in different geologic media would be considered. That would be interesting. There's a great deal of thermal loading information involving welded tuff. However, I don't know that there's that much in the other geologic environments. And I addressed salt a moment ago, but how thermal loading would affect the geologic medium would be considered. That would be I think we would get some good information from a proposal of that nature.
The next question is, for the transportation task, what are high priority disruptive scenarios?
Disruptive scenarios, well, there's the non-spectacular, and by that I mean shaking of the assemblies that would take place that would cause degradation of those assemblies and the casks. There are what I would call non-design basis events where you might have a in simple terms, where you might have a train wreck where the casks with transportation impact limiters would be subjected to crash loads, that sort of thing. There's been a great deal of research in that area, and that research is available online. We would consider something novel approaches, or innovative looks for research in this particular area. But again, there's a great deal of existing research that was done that involved full-scale crash tests of transportation casks with impact limiters.
Okay, here's the next question. This is a big work scope. Will the funding be equally divided between storage, transportation, and disposal?
I think the emphasis at this time is primarily on storage, because the current path forward involves extended storage. And one of the things that we're facing is transporting after an extended storage period. And I attempted to emphasize that just a moment ago in my presentation charts, that we're going to want to monitor the health of storage systems. And one of the presentations I'll be doing here, the next presentation, sensors and delivery devices for dry storage to use nuclear fuel, it will address that those aspects. But storage is very important. We've done a great deal of research. There's a lot of research available on disposal in welded tuffs there's deep borehole disposal information that's available. Again, this would be new approaches and innovative approaches to anything in the three areas. But it's my understanding that that the primary focus at this time would be storage. However, like I say, we would consider innovative and good proposals. I'll use that term for either of the three: storage, transportation, or disposal.
Okay, the next question is, can you describe the prolonged storage needs a little bit more?
I'll touch upon that in the next presentation. Most, or many, I won't say most, many existing utilities are going to dry cask storage, and it's necessary to try to monitor the health of that storage, to get an idea of how it is performing and how it is going to be performing over the years in a variety of locations that range from humid and salt air seaside environments to dry deserts locations. And so there would be a great deal of interest in novel and innovative techniques for helping the Department of Energy to, I keep using the term monitoring the health. By that I mean the integrity of the casks and that sort of thing.